going to have I'm going to make all of these plus signs, multiplication signs, and the subtraction signs I will wind up changing into fractions, and the zeros to ones. So I will now have n times 1 over n equals 1. This is the definition of a fraction. So, and now I will, for the definition of division, I will now change this to 1 over n equals 1 divided by n. Now again, the definition of division allows me to also do this, where I would make this n equals 1 divided by 1 over n. And to reference this out, this would become A, and this would become B. Now to start my proof, using these postulates, I will have, for the identity property, I will have m times 1 equals m. Now, instead of subtracting n from both sides, I'm going to divide n into both sides. Now I have m times 1 divided by n equals m divided by n. Next, for the associative property, I will associate some of these numbers. So I will now have m times 1 divided by n equals m divided by n. And lastly, for the transitive property, I will solve this. So now I have m times, and since I know 1 divided by n is equal to 1 over n, I now have m times 1 over n equals m divided by n. To write this in numbers, if m were to equal 2 and n were to equal 3, I would now have 2 times 1 over 3 equals 2 over 3, which is the same as 2 divided by 3. Unfortunately, we don't have proof 2 for this because it equals the same as I think proof 4. So Claire won't be able to do this, but we are going to skip right forward to Julia.
So to use this in fractions, we will change what I just did into, like, this division sign. It will end up being a fraction. So m times 1 over m times n times 1 over n equals 1. And that is the identity property. Next, as we did in the other one, we're going to flip these two around. So, and that commutative property allows us to do that. So we'll have m times n times 1 over m times 1 over n equals 1. And as you know, it's the commutative property. Next, we are going to use the associative property to associate these two numbers and these two numbers so we can end up solving the equation. So we have m times n in parentheses times 1 over m times 1 over n equals 1. And as you know, this is the associative property. the definition of division allows us to do, we'll bring this down. But as we did otherwise, we would, like in the other proof, we used a subtraction sign. Now we are going to use a division sign. So it's 1 divided by m times n. And again, you're just going to, this is the definition of division. So it's definition of division. New rule, we're going to use A again. A again, not here, but this A, we're going to use that rule in using our next step. So that will be m times 1 over n, 1 over n, m times 1 over n equals, and it will become m times 1 over m times n. And if we were to put this in numbers, we would use 1/5 times 1/3 equals 5 times 3. So this is rule A. 1 over 3 times 5 is equal to 1/15. Now we'll hand it over to Rose, who used our fourth definition of fractions.
Now I will prove the last rule for fractions. M is 1 over n times n is 1 over n equals 0, and that's the identity. Now I'm going to use the commutative and switch the second and last. So now it's m times 1 over n times n times 1 over n, and that still equals 0. And that was the commutative. Oh. Now I will associate. And that's the associative property. Now, using the definition of division, m times 1 over n can be simplified as m over n. Now I'm going to show which rule I use to simplify. This one over here that Natalie had used. So if I use that rule, it then becomes m over n times n over m, which still equals 1. Now, using the definition of division, I can leave n over m here and bring m over n over to the other side. And now, use 5/3 is equal to 1 divided by 3/5. And that now concludes our fraction proofs. Thank you for letting us teach you.